So in this video, we're going to take a look at transformations of the quadratic relations that we've been looking at. We're going to look at those letters H and K that I mentioned earlier and how they affect the graph. When we're talking about transformations, we're talking about altering or shifting the base graph. In the case of a quadratic, that base graph is the x squared. So this is our table of values for our x squared, y equals x squared. Right? We just square each number. -3 squared, -2 squared, -1 squared, 0 squared, etc. And then over here, I have the graph itself plotted out. So I have my vertex at 0, 0. The base graph has a vertex of 0, 0. And then I go over to 1 and 1, and -1 and 1, and -2 and 4, +2 and 4, and then on this graph here, the 3 and 9 didn't fit. So this is our base graph. This is our standard piece that we look at, and we use that to riff off of with our A, H, and K's as we start to look at these. So we'll start with K. So our K value here, our K value denotes a vertical shift. So the K value is added to the x squared. So I have y equals x squared plus K. Okay, so it's added after the x squared here. So we're adding this value to our equation. And if that value of K is positive, it shifts the points of the graph, or the graph itself shifts up by K. If it was +3, it would shift the graph up. Each point would be shifted up by 3. If it's a negative, then it shifts those points, or the graph, points or graph, down by K. So here I have a table of values with our x and then our y equals x squared. There's the y values for this base graph, and there's our base graph already plotted. And so now let's make a table for y equals x squared plus 1. So we're going to make a k of +1 here. Okay, so this is our k, +1. That's k. And if I fill this in, I would have -3 squared, which is 9, plus 1 is going to give me 10. And then -2 squared plus 1 is going to give me 5. And then -1 squared plus 1 is going to give me 2. And as I move through the table here, I'm going to get these as all my values. So each of these values here is shifted by 1. And if we plot this out now, so I'm going to plot this out. So I'll start with my vertex at 1 and 0. So I'm going up by 2's on this graph here. So 1 and 0. Or sorry, 0 and 1. Plotting x, and I'm plotting these two columns, note the x values, and these are the respective y values. So 0 and 1, over 1 up to 2, point there, and then the negative point would be right there about. And then our 2 value goes up here at 5. And then our 3 value at 9 here actually goes up to 10. So I have this graph here. And each of these points on the original graph is shifted up by 1. So I've taken this vertex and moved the vertex up by 1. This point was moved up by 1. So that's what we mean by a shift up by 1. So each of those points just moves up by a value of 1. In the case of a negative, it would shift all those points down by 2. So instead of 10, we would have -3 squared, which is 9, minus 2, which is 7. -2 squared is 4 minus 2, which is 2. -1 squared minus or it's -1 squared is 1, minus 2 is going to give me -1, and then -2, and then -1, or sorry, then +1. No, that is a -1, my mistake, and my ruler, or my eraser has gone. It was stolen by my cat. So that is a -1, and then a +2, and then a +7, respectively, as we finish that table off. And so if we plot those points now, we have our 0 here at -2, 1 and -1, and -1 and 1. And then our 2 value is at 2. And then our 3 value is at 7. And so now I can connect my dots here. And there you see my graph has shifted down. So there's that base graph, and each point has just moved down by 2. So the k value is going to shift that graph up and down along the x-axis, or sorry, along the y-axis. When we're finished up here, we'll actually flip over to the Desmos program, and we'll take a look at how this actually affects the graph in a little better visual sense. So now, if we move on from k, though, the vertical shift, we move over to h. The h value is the horizontal shift. And note that this always works in an opposite manner. So we have y equals, in brackets, x minus h. So the minus h is in the brackets with the x, okay, before the squared. So before we square the x, we have to take away h. This is going to give us a horizontal shift. The k goes outside, the h goes inside. And notice it's negative. Whenever you have a negative sign here, it works opposite. So it's going to do things in the positive direction. So a negative won't move things over to the negative side. It'll actually move things over to the positive side. So h in the bracket, anything in the brackets will work opposite. So a positive h actually shifts the graph to the left. A negative h would shift the graph to the right. So if we take our standard table of values here with our base graph, which I've plotted again, and then we'll take a look at graphing these ones out. So if I calculate these out, what I'll get in each case here is -3 plus 2, which is going to be -1 squared, which is 1. -2 plus 2 is 0 squared, which is 0. And as I work my way through that table, again, I'm adding 2 to each of these x values before I square it. I'm going to get 1, 4, 9, 16, and 25. Okay, so each of these values now is shifted. And if I try and plot some of these out, I got -3 and 1. I have -2 and 0. -1 and 1. And you can kind of see this point's been shifted over by 2. This point's been shifted over by 2. This point's been shifted over by 2. So each of these points is just shifted over by 2 values. And if I connect the dots, I have my shifted graph here. So this is x plus 2. Okay, so this is y equals x plus 2 squared. So when the h is the plus 2 in there, okay, it shifts it over to the left. And then in the case of y equals x minus 3, I subtract 3 from each of these values before I actually calculate the square. So -3 minus 3 is -6. Squared is 36. -2 minus 3 is -5. Squared is going to be 25. And you're going to get numbers working their way down like this here. Okay, notice they're all perfect squares. A lot of times we're dealing with perfect squares values unless we start multiplying by the a value, which is next. Or shifting up and down. But with the h value, a lot of times we're working with perfect squares, so you need to know your perfect squares. It'll help out. But anyways, taking this and graphing these out, going back to this for a second, I added extra points here that we didn't have. We didn't have -4, we didn't have -5, but that shift is illustrated there. So I put the points that I could put on, and they will shift that way. So doing the same thing here, I'm going to add some points that aren't there, but I'm going to plot what I have first. So over here at 3, okay, so my vertex is moved over to 3. My 2 and 1, back to 2, and I'm up at 1 here. So that's going to be this far point, 1, 2, 3, or 1, 2, 3 steps over. Okay, so this point moves all the way over here. And then I have 1 and 4, and 0 and 9. And that's all it's going to fit. But again, because it's going to mirror itself, and each point is shifting over 1, 2, 3, 1, 2, 3. Okay, each point shifting over 3 there, I can actually graph those points that I don't have on my table. And there I have y equals x minus 3 squared. And so that minus 3 shifts each point over 3. Okay? So when we're working with k, it's outside the x squared, and it shifts the graph up and down. Positive goes up, negative goes down. With h, it's opposite, and it's inside with the x. Positive goes left into the negative side, negative goes right into the positive side. And then the last value is the a value. The a value does a couple things for our graph. So before we do that, just a quick look at the term absolute value. You may or may not have heard this before. Absolute value means basically remove the negative signs that are in or on a number. That's basically what it tells you to do. It's the distance of a number from 0, but you just remove the negative sign. So if I have the absolute value of 4 here, these are big long bars around it. Okay, the big long bars around the letter. Big long bars. Absolute value of 4 is 4. The absolute value of negative 3 is positive 3. The absolute value of negative 6 is 6. The absolute value of positive 6 is 6. So you just basically get rid of the negative sign. It'll just make it easier for writing some of the stuff with A. So A is going to do some reflecting around the x-axis, and then it's going to stretch or compress the graph depending on its actual value. So I have a little if-then table that I kind of skewed off a bit here. So if it's positive, the graph is going to open up. If the a value is negative, it opens down. If the absolute value of the a value is greater than 1, so if it's 1.01, 2, 20, 79.68, it's going to make the graph stretch or narrow. In the case of the absolute value being less than 1, so between 0 and 1, negative 0.2, 0.4, 1/2, 1/8, those are all going to compress the graph down, so they're going to push it down, and it's going to end up widening. And we'll kind of take a look at that here. So if we go through the table here, if I start with the y equals 2x squared, so we're just going to multiply each of those values by 2. So we're going to square x first, and then we're going to multiply it by 2. So 9 times, or 3, negative 3 squared is 9 times 2 would be 18. And it's just going to be each of these y values are going to end up being doubled. So there's my doubled set of values. Get that on the screen there. And if I was to plot those now, vertex doesn't move. And then each one of these is just doubled in position. So I can't fit those 3 values on there. But we've now narrowed out or stretched out that graph. Like that. So everything just gets kind of, it's like grabbing these and pulling these up taller. And as you pull it up taller, it's going to get narrower. And I will show you that with a piece of string in a moment. let's take a look at, let's actually do the 1/2 now. We'll do the compression first, and then we'll come back to the negative sign. So the the 1/2 means we're going to take each of these values, we're going to square x, so -3 squared is 9, divided by 2, or multiply it by 1/2. So we're going to get 4.5 to 0.5, 0, 0.5, 2, and 4.5. And again, what all I'm doing here, I'm doing them quickly, but all I'm doing is taking this x value, replacing the x here, so -3 squared, and then multiplying it by 1/2. And so now if I plot those on the graph, it's going to be a little tougher to do because I'm going to squeeze them in here, but I got 0.5 at 1, 2, and 2, and 3, and 4.5, put right there. And so if I do the rest of these, so what I'm getting here now is a wider looking graph, something like that. So we're actually pushing this base graph down, and as we push it down, it needs to widen itself out. And then lastly, if we do the negative, then we're going to do this, and make sure you do this right. Wait, when we do y equals -3x squared, it's not squaring that negative sign up front. That's why we use the brackets here, right? So there's the -3, and when we do the +3, it's going to be, so we make sure we use the brackets here. This is why the brackets are important, because that negative sign is not squared. So the answer, -3 squared, here, that's 9, but it's -9. That's 9, the answer is -9. So this here actually switches all the signs to negatives. It's the same as, so this here, y equals -x squared, is the same as -1 times x squared. Okay, so you got to treat it separately. This x squared is separate from the negative sign when it's written like this. So now we can plot those points, and all we have is our base graph, same vertex, but all the points are flipped over to their negative counterparts on the y-axis. So we have the same base graph, but it opens down. So a graph will open down when the a value is negative. When the a value is, the absolute value of the a value is less than 1, you're going to compress the graph and make it wider. When it's greater than 1, you're going to stretch that graph out. It's going to go up faster. And have quite a piece of string, but I do have the power cord for my laptop here to kind of show you this. So here's a quasi representation of what we have. So we kind of have this parabolic shape here, and when I stretch it out, when I stretch those points out, you see that the lines get closer together, and then when I widen it, or when I push it back down, sorry, when I compress it, it ends up pushing those sides wider. So the sides get wider or narrower as I stretch it out or try and compress it. Okay, so that's what that stretch and compress means, and those are the proper terms that we use. But you can say it gets wider or narrows as well. So the a value, positive or negative, makes it open up or down. And if you just look at the numerical value, not the positive or negative sign, but the numerical value, if it's greater than 1, it's going to stretch. If it's less than 1, it's going to compress. Okay, and just one last thing on this part. When we're sketching a graph, so if we have y equals x squared and y equals x squared plus 2, we want to sketch them on the same axes. What sketching means is that we want to quickly draw the graph. We don't want to have to put all the points and make a table. So we just say that, say our x squared is maybe this. And that's a really bad x squared, but it's approximation. Y equals x squared. I know I got my vertex here. Maybe I got 1, 1. My vertex at 0, 0. Something like that. And then if I had y equals x squared plus 2, well, that's a k value of plus 2, so I'm going to shift that graph up. So I'm going to try and make that same graph here. Shift up the vertex. Shift up this point here. And then there'd be a mirror one here. So we're looking at something like this. And this is y equals x squared plus 2. Okay, so this is all we're doing, and then we can maybe label that as 0, 2, and so on. So you're just doing a quick representation. You could do the same thing with y equals x squared and y equals negative 1/4 x squared. And then I could just draw a quick set of axes. Draw my y equals x squared here. Okay, stretch that down just a little bit. There we go. So there's my y equals x squared. And then the negative is going to flip it, and the 1/4 is going to compress it, making it wider. So I'm going to have a wider graph. So I'm going to do it step by step here. This is what I would actually do. I'd make a wider graph. Just dot it out really lightly. Okay, and then I'm going to flip that underneath the axis. And I'm going to exaggerate a lot of the changes when I'm doing a sketch. So I'm doing a sketch, I'll often exaggerate the changes so that we know, okay, this is now widened out as compared to the initial graph, and it's also flipped upside down. All right, so there's some questions that you can check out of the textbook, and then in the next little video I will have a more on this AH and K and how they get affected in the Desmos program.